Okay, so this is the other type of machine that we have. This is the other machine. The first machine we showed you was a machine where the wire feeder is housed inside of its own case. It's basically an all-in-one. This machine happens to be a multi-process machine. This first machine we're going to look at is called an XMT 350 MPA. This happens to have a 2-head 74 series drive head on it, or a feed head on it, and it's very basic to what you just saw. Here's the drive rolls on this unit. The wire comes out, the wire's going to go in through here, into the back of this drive roll back here, come off of this spool, go into here, go through the drive rolls again. You want to make sure the drive rolls are the size that you want for the wire. If you're running 035 wire, 035 filler metal, you need to make sure the drive rolls are set for 035. You need to make sure that they're catching on the rolls like they're supposed to. Above on this machine is a tensioning device to be able to tension the wire. We didn't really talk about tensioning on the other one as much, but once you guys kind of get down here and start working with the machines, you'll understand how tensioning works. Okay, this is an MPA. I'm going to come in here and turn this on. Put this part on. Now it's going to run through its diagnostics. And it's running through its diagnostics. It says it's an MPA. And you got a voltage reading. And you can see that voltage reading right on the front of this machine. Right there, it's showing you 19. Now, one of the things we want to look at is this little plate right in the front here. That little plate has two different types of settings. It has settings that are designed for constant current, and it has settings that are designed for basically constant voltage. The settings for constant current are on the bottom, and it's going to tell you that with that orange line. The orange line tells you that when it's in these settings down here, any of these, we'll do a little shot up. And you see that blue light? That blue light means that this thing is electrically live, okay? And it's trying to find what it wants right now, and it can't. So we're going to back up. Okay, so this machine is going through a little deal, and now we're going to go and we're going to find, we're going to be working mostly with these upper level settings. Now, for you guys that are doing shielded metal, we're going to talk about your stuff here in a minute, but for the time being we're just going to stick for you MIG guys, because you shielded metal guys and flex core guys, you're going to be using the same exact kind of setup as we do for the MIG. Shielded metal guys, you're going to be doing something a little bit different. Okay, so that's the bottom of the machine. Now let's take a little cruise up to the upper part of the machine. This is the feeder. And the feeder is actually doing all the control right now. And on this feeder you have two sides. You have a left side and you have a right side. And depending on what you're doing on each side, the feeder will change then to access the voltage that's on that side. Now, this is a pretty straightforward M70 series feeder. It doesn't really have too many bells and whistles. It's got a purge button and a jog. It's got a trigger hold switch, and it has that replicated for both sides. Now, here's one of the things that happens with this machine predominantly. We go into this machine and we hit this button. You got inductance. And we can switch through the programs. So we got a 035 steel program, you got 045 steel, you got a flux core program, you got stainless, you got flux core in about 3 different sizes, you got metal core, you got all kinds of things. You got all kinds of programs in this machine. So you got to tell it what you want to weld. So we're going to be welding with steel in these machines predominantly. So we want to go through here and we want to find 035 steel. Okay? And then the next thing you got to do is you got to tell it what gas you're going to use. So we're going to use a CO2 gas. It's a CO2. And when I hit this, a lot of times when I change programs, it'll say loading program. And when it says that loading program piece, you gotta let it load, and then it's ready to go. So now, the way this machine is set up right now, if I want to change that voltage, I could actually go to the upper part of the machine and change the voltage. Let me give you guys a little shot of that. So there's the upper part of the machine, and we can actually change a voltage up here, and we can change a wire speed up here. So once we get the machine in the program that we want, we really don't have much more to do with the power source other than making sure it's on and turned on and off, and make sure the connections are right. We're going to talk about those connections here in a minute. Okay, there's two connections, actually three connections on the front of this machine. You have this upper one here, which is a control cable for the power source for the feeder head. Then you have the connection right below it is a positive lead, or the positive lug, and that one should come from, this one should come from the feeder into this positive terminal. Because everything we're going to do, for at least for you MIG guys, is going to be run off of that positive lead. We're going to run DC, EP for you guys. And then the ground, the work clamp should come off of the bottom one or the negative. Now, okay, for you flux core guys, there's programs in these machines to run flux core as well. But for you guys, you got a little different scenario, because one of your wires, one of the filler metals you're going to use, you're going to have to move this wire, okay? Because the wires, it's going to be the wrong polarity for what you're doing. So you're going to want to switch that. The rest of the machine pretty much sets up very similar, but you're going to want to make sure you understand that for self-shielded wire, you got to switch this lead. You got to run DC-EN for those wires. So what does that mean for you MIG guys? Well, for you gas metal arc guys, if you get to a machine where they've been welding with self-shielded wire, odds are they're probably got it set in the wrong polarity. So you need to check that every time you come up to a machine. You need to go through this little pre-flight to make sure everything's working correctly. Okay, for you guys that are running shielded metal, we're going to switch this to run shielded metal. There's shielded metal. Okay, now, more than likely you really didn't see much happening. But we're going to do a little bit of panning back here to show you what the hell's going on. See that blue light? This one right here? When that blue light is on, this thing is electrically live. In other words, all the work clamp is looking for electricity, the stinger or the gun is looking for electricity, and if I short that piece of equipment out, in other words, if I make contact between the contact tube or the electrode holder or whatever I got on there with the work return lead, I'm going to get arc. So you need to be careful on these machines. When that blue light is lit, this thing is electrically live, and you need to make sure that you're in the right spot when that happens. Now, once we get that part set up, I do believe if we want to change amperage, all we're going to do is change this knob over here. But when we're in that amperage mode, we can change the dig on this. Dig is kind of like inductance on the other machine. Oh, you MIG guys, you've got inductance control on this machine as well. But that dig control, that's going to give you the ability to make the rod either penetrate more or not as much. Makes the arc more energetic if you need it that way. It's a good feature to have.